Hi guys, welcome to our very first chemistry video in our flipped classroom. So in these videos, I'm usually going to start by talking about some question that we want to answer and maybe giving us some vocab and then I'm just going to go through and talk about those important concepts. It's important that you understand that since we're in a flipped classroom, this really gives you the flexibility to watch these videos at your own pace. You can speed them up, slow them down, pause them. You can rewatch them, use them really as you want. This is designed for you to hopefully give you a resource that you can go back to as many times as you need. Um, the first chapter or two, they're going to be a little lighter, and we'll really dive in once we get to chapters, the end of chapter two. And then from chapter three, we'll really hit the ground running and we'll go from there. Let's talk about chemistry. Let's introduce ourselves to it. So always you're going to hear chemistry is called the central science. And there are many reasons for that, but just on a quick level, you can see this picture I have here and think about, chemistry. Well, if you're a biologist, say the DNA molecule, it's a molecule. It's made of atoms. You need to understand chemistry to study it. Astronomy. If you're looking at a nebula and you want to know what kind of stars are going to be formed out of it, well, you have to know what elements there are. Again, chemistry. Even geology. We talk about the Earth's crust. Well, you've got to talk about what makes up the Earth's crust or the atoms and materials that make it up. So, and we could go on, right? Everything does essentially tie into an understanding of how the world works at its most fundamental level. And that's what we study as chemists. Chemistry is the study of atoms and materials and how they interact. So, I do want to talk about why it's important, right? I mean, hopefully you kind of like chemistry. You're in here. You've chosen to be in Regents chemistry. But it is worth knowing like what is so important. So I have here something called the Haber process. This was a process that was invented in the early 1900s. It is a chemical reaction that's done that takes atmospheric nitrogen, combines it with hydrogen gas, and produces ammonia. Now that's it's a simple chemical reaction you can see here. Um, that's useful because this ammonia is fertilizer and it is a precursor for all fertilizers that we use. And so when we produce this fertilizer, you can actually see this graph here. I've graphed the world population here and the year. And what we can see is that as our green line, which shows us the total nitrogen being produced, we had that Haber process get invented right about here. And you can see once that Haber process was invented, we have exponential growth, which has of food production and therefore our world population. So chemistry directly caused our population to increase from the around 100 or 1,000 million people all the way up to 600 million people. I'm sorry, 6,000 million people or 6 billion people by 2000. So you can see this massive increase in human population directly linked to somebody unearthing a chemical process that was useful. I can't imagine a process more important for human evolution than something that multiplies our population by 6 and is continuing to grow with some caveats, maybe happening soon. We'll see. But continuing on as to why it's so important, if we think about how the US gets energy, where it comes from, we are looking at chemicals or chemistry, solar radiation, maybe the only one that doesn't directly involve chemistry. It's more physics, but we do use chemistry to like build those solar panels. But coal, nuclear power, oil and gas, natural gas, renewables, all of these come down to chemical processes. And understanding these chemical processes will make you a more informed person. It'll let you make better decisions and more informed decisions moving forward. Now, you also might see chemistry being used as like something to solve crimes. Here we have some crime scene being investigated, some people collecting evidence. They're going to test it, figure out what material it is, and possibly use that, in a court of law. Even further, we have research lab here, somebody trying to investigate some new phenomenon. Precious materials, diamonds, gems, that kind of things, precious metals like gold. These all have to do with chemistry. The difference between ruby and diamond and ruby and emerald is simply the atoms in the crystal. We have forging and blacksmithing or any kind of metallurgy if you're interested in any kind of metallurgy is, of course, going to be chemistry because it's chemistry that makes up those atoms. And even we have colonizing, say, Mars, like colonizing another planet. We will need an understanding of chemistry to be able to colonize other planets and know what a good planet will be. So I hope that gives you an idea of why chemistry is so important. I mean, I consider it the most important subject. I mean, I chose to dedicate my life to it. So, take my word with a grain of salt. Now, moving on, we do have some vocab words that I want us to get into. So copy these in your notebooks if you want. Just make sure you understand them all very well. Chemistry is the study of matter and the changes it undergoes. Matter is anything that has mass and volume. Volume is the amount of space something takes up, where mass is a measurement of the amount of matter. Make sure that you understand that weight and mass are different, right? Weight is the effect of gravity on mass. So this actually matters quite a bit for chemistry because if I think about mass, this is a quality that does not change. So let me select here. Mass, we can write maybe in your notes, this is fixed. So mass does not change for a substance. If it's, you have it on Earth, say this guy, he's going to weigh 50 kilograms. That's his mass. He will also have that same mass on Mars and that same 50 kilogram mass on the moon. Okay, so the amount of stuff in him is the same. He's the same person, but his weight can change. If we are on Earth, that person maybe has a weight or that feel of gravity pulling them onto Earth of 490 newtons. If they go to Mars, a much smaller planet, maybe their weight is only 185 newtons. So their weight is less, even though the mass is same. That's because the planet is smaller, less attraction. And then if we go to the moon, even less weight there, only 80 newtons for the same person. Again, a smaller planet, less pull on that mass. Okay, so mass and weight are different. Please don't use them interchangeably. So some things that are matter. We have things that you can touch, right? That would be like your desk, a chair, the air around you, water. This would be food. This would be you. Anything that you can physically touch and that your body can interact with would be considered to be matter. Something that, again, it has both mass and volume. Things that are not matter. We have things like sunlight or just light. We have heat. We have sound. We have energy. Okay, so the things that are not matter, again, these are things that you feel them, you interact with them. Like we feel sound, we feel light, like and warmth. Like we can feel them. They're there. They are real, but they're not made out of physical substance. You can't capture sound in a jar. You know what I'm saying? Like it's not made of atoms, so it's not matter. Okay. And that's my spiel about what, the basic vocab words of chemistry. These are like every day we'll probably be talking about these. Very important. Okay. Now, it's also important, and in this video, I also want to talk to you guys about the branches of chemistry. So just like most subjects, chemistry isn't just one thing. There are 5 major branches that we study as chemists. You have probably heard of organic chemistry. This is the type of chemistry that deals with things like carbon, oxygen, hydrogen, those atoms that you find in everyday life. Organic chemistry is actually named for the concept that these things come from life or they are found in living molecules. So organic stuff is a branch of chemistry that just deals with carbon, hydrogen, oxygen, those things you find in life all the time. Inorganic chemistry, on the other hand, actually is my specialty. I was an inorganic chemist, deals with everything else. So if it's not a part of organic chemistry, it's a part of inorganic chemistry. Here we deal with metals, all kinds of reactions that involve non-metals, big stuff, small stuff, you name it. Inorganic is kind of a catch-all. We have analytical chemistry. This is testing. So if you say are being tested for performance enhancing drugs, you send a blood sample to an analytical laboratory, they run some tests and give you a report of what was found in the blood. Again, an analytical lab. We also have biochemistry. This is specifically the focus on the chemistry of life. That would be something like studying how chemicals affect a cell, studying a DNA molecule, or how to edit DNA molecules. But if it's directly involved with life itself and living organisms, we call that biochemistry. And then finally, we have our physical chemistry. This is entirely dealing with how matter works, theories on nuclear physics, the calculations of heat transfer. Physical chemistry tends to be a little bit more mathy, and a little bit more rooted in combining matter and energy and those principles of how the universe works. So I'm hoping that gave you a little sneak peek of what we're going to be talking about in chemistry this year. I do have some more things to finish up for chapter one. I will say that in the next video. I do try to limit these videos to be around 10 minutes, and I'm about at that point right now, to hold your attention, hopefully. Anyway, guys, thank you so much for listening. I hope you enjoyed it, and I will see you guys in the next video. Bye, guys.